Welcome to this video in the MRDCL Fundamentals series. In this video we're going to be looking at summary tables and how you can put data from more than one variable on the same table side by side. And we're going to start with this table here, where the table that we're trying to achieve is something that's quite common in a market research questionnaire, where you've got a series of rating scales. In this case we've got 8 rating scales. And what we're trying to achieve is that we have the rows down the side here with the responses to those rating scales, and across the top we've got all of the rating scales side by side. So these are just independent variables. So rating 1 is a variable, rating 2, 3, 4 up to 8 are all 8 separate variables. So we're going to look at how we can achieve that, and then we're going to move on to look at how we can produce the same table but round the other way. So let's start by looking at the script and closing this file. So I'm going to close this file, and here's the script. So nothing very unusual at the start here. You can see there's a data statement here, data 50. That's picking up those 8 texts, rating 1 to rating 8. And there's a set command here that is setting an index called ratings to the number of items that there are in data 50. So that's a very common way of handling rating scales, so that you can use a loop and so that it's automated for you. So in this particular case, ratings will take a value of 8 because there's 8 items in the data statement 50. And now we are okay to do a loop which is going to run from 1 to the number of ratings. In this case it happens to be 8. So first of all, I'm going to define here a variable called xq2, and that will pull in the letter of the alphabet, A, B, C, D up to H. And the data location is A plus 112, so that will be location 113. And we're picking up codes 1 to 5 and E for the error bit. And then after that, we're converting that to a multi, where we're picking up Q2, and we've got a subtotal of top 2 box effectively of anybody that agrees. I must admit I'd prefer to see this defined as xq2 tilde array, so that you're defining it from the previous variable just for tidiness. And then it's going on to have the labels. Now you can see here with the labels, this has to be a multivariable, of course, because a respondent that agrees will go into the first bit here, and they'll also go into one of the 2 codes here if they agree. So it has to be a multi, that variable, even though the raw question, if you like, the data on the questionnaire will be single coded. So we've got subtotal here, agree, but we don't have a label control setting the value for the subtotal, because it could be 1 or 2, depending on whether they agree or strongly, or whether they agree just quite strongly. So here we go. The first one is labelled as 2. The second one has a score of 1, 0, -1 and 2. And then the not stated on the end has no score on it and is 0 suppressed if it happens to be blank. You'll see below it's got some H labels, and I'm going to come back to those in a minute when we look at the second table. I want to move on though to the tables we're producing. So here we're producing a table for each rating statement by a banner, which happens to be just the age. And that's absolutely fine. So that's going to produce me 8 tables there. And now we're going to look at doing that summary table that we looked at the beginning of this video, where we had the 8 columns side by side. So this is going to give me 8 separate tables called 1A to 1H. But now I want to do this table where we put all the columns side by side. So let's look at one way of doing that. One way of doing that would be to define a dummy variable. And the dummy variable is called Q2dum. And in here, in brackets, it specifies the number of items. So actually what it's going to do, it's going to substitute the value of ratings with the value of 8 in this case. We could have actually put Q2dum 8 if we were sure that it was only ever going to be 8, but we've done it by counting them from the data statement. So that's dummy defining a variable, and that's another way of specifying that would be to put false 8 times. I think I've done that right there. So we've got 8 falses. That's another way of doing it. But I've chosen to use the dummy definition with bracket 8 bracket, or in this case pulling in the value of ratings, which is 8 bracket comma. The labels for these ratings will be running from rating 1 down to rating 8, or just pulling in the values in the data statement. You'll see this expression here, start SLE. This is something that's very useful. It means at the end of the loop, or the last time around the loop, we want to skip to the end. And the reason for that is we don't want that semicolon after rating 8. We only want it after 1 to 7. If we look in the listing file, we will see that if we go to that variable there, you'll see that what it's doing, it's pulling in 1 colon 2, 3, 4, 5, 7, but after 8, it's skipping to the end of the loop and missing that semicolon so that the loop can close with a quote comma, because another semicolon would tell MRDCL there's actually a blank 9th label in there, and that would cause an error. So let's go back to our script, and we can now look at what we're going to do with that variable. Now what I'm doing here is I'm specifying a table which has the rows as Q2A, so that's basically the first of those variables, and it's cross-analyzing it by Q2done. That's the variable we've just defined, which has the 8 labels for the 8 rating statements. And you can see it's pulled in 2 important format options here. They are NITB and NPTC. So what that's doing effectively is it's saying don't increment this table, not increment the table, and don't print a total column. So what that's making, you can think of it as, is the shell of the table. It's setting up the rows of the table to have total, subtotal of agree, strongly agree down to strongly disagree, with across the top the rating 1 to rating 8. So it's making an empty table for me. Now what it's doing here, it's going to be actually specifying what I put into the columns. So we're doing the loop of 1 to 8 again, and what we're doing here is we're saying I want Q2A times 1, Q2B times 2, up to Q2H times 8. And you're not usually allowed to specify what column you want to go things in, you want data to go into, except where you've already defined it. So we've already defined dummy, table T2 here, as a dummy table that's got the rows it has and 8 empty columns. Now I'm putting into those 8 columns the different data for Q2A through to Q2H. So let's see that in action. Let's see what it produces. Let's look at the listing file first. There it is. So here we go, the 8 tables as they are, and then we get to the dummy definition, and now you can see very clearly that we're redefining table 2. That's why table redefinitions are allowed in MRDCL. It's not a new table, it's just redefining what's going to go into the dummy table that we specified above. In the first column, I want Q2A, second column Q2B, right through to Q2H in the 8th column. And just to see that as a table now, let's quickly go to table 2. Sure enough, there's our table 2 with the 8 columns side by side and the labels taken from the first table. And just to see that in action more fully, let's go to table 2 again. Let's comment out this row here. And now we've got no definitions for the table. And now you can see it's an empty table, table 2. And if we go to table 2 now, that's what that dummy definition did first of all. It made me an empty table so that I can put in the columns one by one in that table. And of course, if I was to go to table 2 once again, take those off, and actually only change this to 4 columns, it would only increment the first 4 columns of my table. Let's have a quick look at that. There we are. We can see now that all we've got is 4 columns incremented rather than all 8. So obviously I need to correct that, and I'm going to set it back to what it was before and change that to the value of ratings so that all 8 columns are defined. So that's how we can do that table, one way of doing it. We're going to now look at producing the same table but horizontally. So let's look at our tables again. Let's save our work here, go back to our tables and look at the third table. Now the third table we're trying to do It's exactly the same table again, so it's a summary of the rating scales. This time we want the rating scales as the rows and the rating statements as the rows, but across the top we want the agree to disagree with the mean score on the end. And as a result of that, we're percentaging it the other way around, so we want horizontal percentages. So there is an extra trick you need to know to do that. So let's look at the variable first, because there's an extra thing that you need to do when you do a mean score horizontally. So before we saw the labels for Q2A through to H, and you may have noticed, although I didn't mention it, that we had vertical labels set there. When we come to the horizontal labels, I've got a separate label set. Now you'll notice the last one here, this one here, is an extra row in there, which it sort of almost breaks the rules of MRDCL. It really should have 6 labels there, plus not stated, for the 6 responses, so 7 in total. But actually we've got an 8th one here, mean score, and it has in it the word mean score, D1, and T equals AVG. Now, T equals AVG means that I only want this format option. The T means only apply it to this column of the table. It doesn't work with all format options, the T option. It only works locally for some format options, mainly statistics. So T equals AVG means I want a mean score, and what's more, I want only want the whole numbers to come out. I don't want percentages, because percentages on a mean score would be meaningless. So I'm suppressing the percentages from that and just showing the whole numbers. And that's given me 1 decimal place, so it matches the table I had before. Now that's compiling because it does, MRDCL recognises that because it's got TA equals AVG on it, that it's what you might call a special column or a special piece of text that isn't really a response to the variable in the way that usual responses are. So this is something that's almost anomalous when you're doing these sorts of tables. Now that we've done that, we can go down here and I can now say that my table 3 is the other way round. So it's Q2 dum by Q2A. Again, it's not incremented, but this time we've got some different options. So I want to not print the horizontal title, so that's going to hide the horizontal title. I don't want to print the total row this time. I do want the total column this time because I'm reversing the way around it appears. I want horizontal percentages because we're tabulating the other way around, therefore it makes sense to show the percentages the other way. But I don't want the column percentages because they would be meaningless, so I'm turning those off. And then it's basically the same principle. We have a local VT. That VT, as it did above, up here, means that it's going to replace any base title, vertical title that has been specified relating to the variables in the dummy definition. So that'll override the standard title that would have been pulled in with a local title here that's going to be superseding the basic title. And then really this is exactly the same as we've got above, but the other way around. So this time we've got A times Q2A, which means we get 1 times Q2A. So we've got row 1 by Q2A, row 2 by Q2B, down to row 8 by Q2H. And again, that can only work because we've got a dummy definition here where table 3 is already specified. If I'd left that row out here, if that row got removed, the dummy definition, this would error because it wouldn't know how to deal with a table that hasn't been defined when you refer to row or column numbers only. So let's have a look at that running now. Let's just see what we get on our table. Go to table 3, and we can see now, sure enough, we've got the rating statements down here, our responses across the top, and the mean score comes at the end here, like an extra column in the table, which is not really a response for the variable itself. Now there is another technique that we can use here, and that's using manip to move figures from columns of tables into a new table. So let's explain what I mean by that. Now what I'm going to do is I'm going to copy that dummy definition of table 2. I'm going to call it table 4, and you'll remember this is just going to basically make me an empty table. And what I can do now is I can actually move the figures from different tables into my empty table. So what I'm thinking of doing here is I've got these tables 1A through to 1H, and what I want is the total columns of these 8 tables, and I want to move them into the 8 columns of my table 4. So the way I can do that is by going into Manip. So what I'm asking for here is on table 4, I want to manip table 4, column 1, and I want to set it equal to the total column on column 1A. So column 0 means give me the total column, and that will, with finish manip after it, succeed in moving the column 0, or the total column of 1A, into column 1 of table 4. Now I want to do that for all 8 columns, so I'm going to change this to a loop. I will change that 1 to A, so we get columns 1 through 8, and I'm going to change the letter of the table to tilde A, so it goes 1A, 1B, 1C. I need to close this loop, of course, and now if we run this, I can look at my tables, go down to table 4, and you can see it's produced exactly the same table as table 2, but it's done it in a very different way. It's taking these, this is effectively copying column 0 from table 1A, this is effectively copying column 0 from 1B, and so on through to the 8th column that's coming from table 1H. So that shows you an alternative way of doing the same table, and how you can use manip as well as a way of creating summary tables. So that completes this video on producing summary tables where we're putting things side by side or underneath each other in a summary table. There's another video that follows on from this for mean score summaries, which again shows you different techniques for handling mean score summaries. Thank you.